In this video, we're going to look at questions 8 to 11 in exercise 2b. We're told that an athlete runs a 100 meters race in 12 seconds. Starting from rest, she accelerates uniformly to a speed of 10 meters per second. Calculate the acceleration. Okay, well, if we do a time velocity graph here, she accelerates to 10 meters per second. And then continues, and if we count this as the finishing point, we know that the total t is equal to 12. So if we call this t, this is 12 minus t. And we know the total area is 100. So we get the area to two shapes, half the base by the height for the triangle, shape 1 and shape 2. So this is 1/2 t by 10 plus in shape 2. 12 minus t, also by 10, has to be equal to 100. So we're going to get 5t plus 120 minus 10t equals 100. So minus 5t will be minus 20, or 5t will be equal to 20. So the initial time to get to 10 meters per second is 4. And obviously acceleration is going to be my 10 divided by my 4. That's going to be 2.5 meters per second squared. On to number 9. A cyclist covers a distance of 350 meters in 18 seconds. Starting from rest, he accelerates uniformly to a speed of 25 and then continues at this speed for the rest of the journey. Calculate the time spent accelerating. So very similar again, time velocity graph, T and B. Accelerates, continues at the same speed, and this is my graph. So 350, S is equal to 350, the total distance covered. 25 is my max speed here, and he accelerates uniformly, continues to this speed for the rest of the journey. So I have my time, 18. So I have t and 18 minus t, and I have the distance again. So I got half t by 25 plus 18 minus t by 25 is equal to 350. 12.5 t, 18 25s plus 450 minus 25 t equals 350. So that's going to give me 12.5 t being 100. So t would have to be 8 12.5 is 100. Question 10. Max speed of a car is 40. Max acceleration 2. Max deceleration 8. And the car has to travel a distance of 700 from rest to rest. What is the minimum possible time? So let's draw time velocity graph with some information on it which will help us. So accelerates, continues at this speed, decelerates. So we have max speed is 40. A is equal to 2. My deceleration is 8. I'll call that D. D is equal to 8. And we have distance is 700. So we can get the times in here and here. So here my time is going to be 40 over 2, 20 seconds. And here my time is going to be 40 over 8, which is 5 seconds. If I call this one X, we can then say that I'll number them 1, 2, and 3. So 1/2 time is 20, half of 20 by 40 is the distance covered in that sector, plus X by 40, number 2. And then in number 3, I have half this 5 by 40, and that's all equal to 700. 2040s are 800, so we have 400 plus 40x, and half of 200 is plus 100 equals 700. So 40x is going to be equal to 700 take away 500, which is 200. So my time here is going to be 5. and adding them all together, I'm going to get 20 plus 5 plus 5. 30 seconds. Number 11. Okay, quite a long one here. A racing car covers a distance of 8.8 kilometers from rest to rest. Accelerates uniformly in the first minute. So if t is equal to 60, to reach max speed of 40. Hold speed for a certain time, we don't know, we'll call it t for now. And then slows uniformly to rest with retardation of magnitude 3 times that of acceleration. Okay, so times 3. Okay, let's do a distance or a time velocity graph for that one. So my car, it's going from rest to a max speed, it's going along, and then it's decelerating. So I call my acceleration A, my deceleration is 3 times that, 3a. The max speed was 40. So I can, first of all, I can get my A. So we're told it was in the first minute, so I've got a 60, and I've got, I call this T1 and T2. So half the base by the height is the distance covered in here. That's a 40, just let me tidy that up. It's going to be 1200 meters. What about calculating A? If you want to jot your formula down, V is equal to U plus AT, or else you can see what's going to happen in these cases. 40 is equal to my 0 plus A times 60. So you can see A is going to be 40 over 60, which is 2/3. And if it takes 60 seconds to go up to that speed, and we're decelerating with 3 times that acceleration, it's going to take me 60 divided by 3, 20 seconds to come back down here. So I can put my 20 in here. I can get the area of that one too. So this is number 1. This is number 2. Half 20 by 40 is going to be half of 800, which is 400 meters. It's going to give me a total of 1600 meters. I think it was 8.8 kilometers. Let me just double check. 8.8 kilometers is the total distance. So what are we left with? 8,800 minus 1600 is going to give me 7,200. So therefore T1 times 40 is equal to 7,200. So T1 is equal to 72 divided by 4 is 18. So 180 by 40 is going to give me 7,200. So total time is going to be 60 plus 180 plus 20, which is equal to 260 seconds. What were we asked for? Find the time taken. Okay, so we have the time taken, 260. Now, what are we asked in part 2? If the max speed over the final kilometer of the journey is restricted to 20, show that the time taken from rest to rest would have been at least 22.5 seconds longer, assuming that the rates of acceleration and deceleration are the same as before. Okay, let's draw a graph for this guy. So what's happening? The last kilometer, there's something happening here. So let's look at the first 7,800 meters first. Accelerate, max speed. So the area of this one stays at 40. We know t is equal to 60 here, and half of 60 by 40. Again, it's going to be your 1200 from up above. So 7,800 meters minus 1200 meters is 6,600 meters, 6,600. So if I get t in here, I'll call it T1. T1 by 40 is equal to 6,600. 40 T1 is equal to 6,600. So I'm going to get T1 is equal to 660 divided by 4. So T1 is going to give me 165 seconds, I think, 165. Now, so there's a kilometer left. Let's see what happens. We slow down to 20, and then we have to continue at that time and then slow down again to get to the finish. So there's going to be 3 actually extra parts here. So we're slowing down to 20, then we're going along at 20, and then we're slowing down to the finish. So let's have a look at these 3 sections here. We can definitely get the finish in here first. So at this point we have a 20, and my A in part 1 was 2/3, wasn't it? 2/3, and 3 by 2/3 is going to give me 2 meters per second squared for the deceleration. So I'm slowing down from 20. So I can put it into the formula here if you want. So I'll call this section 3 here. What's happening in number 3? V is equal to U plus AT. V is equal to 0, U is equal to 20, and A is equal to 2. So time is 10 here, you can see that. So 0 is equal to U, which is 20, plus 2t. Well, it'll be minus 2t, won't it, in this case with deceleration. So t is equal to 10 here. So 10 seconds. So I've got my 60, my 10, my 165. Now I'm looking at this section in here and this section in here. Just seeing a mistake I've made. That actually 7,900 happens at this point. This is my last kilometer in here. So let me just get that last kilometer, and then we'll go back and just fix what we've done wrong. Last 1 kilometer. So my half by 10 by 20 plus, and this is a rectangle in here, and the height of it is 20. We'll call the bottom of it x, and so we have 20x. That's going to be my 1000. So 200. So I'm going to get 100 plus 20x is 1000. 20x is 900. So x is equal to 90 divided by 2, which is 45, and that's seconds for me. I'm going to work backwards now. I'm going to get this. I'm going to color this one in red. So this one here, the red bit. So my initial velocity was 40. My final velocity was 20. My acceleration stays the same as up here, minus 2. And I'll call time t. So using v is equal to u plus at. Namely, me to find the time. V, 20. My initial velocity of 40, and I'm slowing down with an acceleration of 2. So I'm going to get 2t equals 20. So t in this case is 10 seconds. If we look at the distance covered in this shape, we are going like this, where we have our 40 and our 20. So I've got this is going to be t was 10. So if t is equal to 10, so I have 10 by 20 plus half the base, which is 10, by the other 20, which is from 20 to 40. So it's going to be 200 plus half of 200, which is 100. So that's going to be 300 meters. Okay, so that just should leave me with this T1 here, which we initially got, but we know is wrong. So let's just work back to get this T1. So we have the last 2 sectors was a kilometer, so that's 1,000. We just got 300 for the previous one and the 1,200 from the beginning. So that's going to give me 2,500. So that leaves me with 6.3 to give me my 8. So therefore we get T1 by 40 is equal to 6,300. So T1 or T is equal to 630 divided by 4. So that's going to give me 157.5 seconds. So the total time I think we've asked for here, the total time, at least 22.5 seconds longer. Okay, let's look at the total time. So my total time. So I have my first minute. in the first sector. Then I had the 157.5. Then I had, what did I have? I had a 10, and X worked out to be 45, and my next time worked out to be 10 as well. So 2 10s and a 45. And that's going to give me a total of 65 and 60, 125 and 157.5. It's going to give me 282.5. And what was our original time? 260 minus 260 is going to give me 22.5 seconds longer. So just be careful not to make the mistake that I did in this question. Work backwards rather than getting the second sector first.